As the topic shows, we're going to look at a quick overview of machine learning, what it is, and then machine learning model. So what's the difference between machine learning and also having machine learning model? What constitutes a machine learning model? And what is the machine learning process? So it's going to be more of a review and a reminder, a kind of revision for some of our old members, while the new member hopefully will even take a better benefit of it. So in review, what is machine learning? So it's always good to get things right and also correct some of the misconceptions. So often now you see people confusing algorithm with model. So classifier, so data, what constitutes a model? He said, I've seen people talking, for example, someone saying, I don't know the kind of model I should use to train my data. You don't use model to train data. You can only select algorithm to be used. So it is when you add algorithm with appropriate data that you can generate model. There is no model at the beginning of the process. But often than now, we often see many people referring to algorithm as model or model as algorithm. They are not to be used interchangeably. They are two different concepts entirely. So what is machine learning? We say that machine learning can be regarded as a program which is said to learn from experience with respect to some class of task E, a class of task E. And considering the performance measure P, if its performance at task T as measured by P improves with experience E, that is, as we provide more data sets, then the system is able to improve its performance over time. If you have we have only 100 samples, if I bring in 1,000 samples, they may also make it to even learn more, because every sample data is providing opportunity for the system to learn from experience. And that is why when you want to build a machine learning model, what do you look for? You look out for the data. Often these data sets, they are often available in our system and they are waiting away. We bring in this data in the past. And this data in the past, if we are talking of supervised learning, it's expected that we know the input for them, we know their X1, we know their X2, we know their X3. Then we are going to be also have the Y, the target. The target is also known. So we have sample one. What is the feature? Then what is the value that we got the last time we did the experiment, for example, in the experimental data? And often than not, we spend more time in the laboratory to get this Y. It's always more difficult, very difficult to get that Y, that output, especially in material science and engineering. So if we can refer back to our whole data in the past, we found several experiments. Some of our students have taken the time. However, it is time for us to take advantage of this unique technology, that if you can provide all these old samples, of course, you are done with them. They're actually waiting away. Bring them back, and they provide us with the input, and then the output is there already, because these are past experiments. Then once we have enough data samples, the more the better. The more the number of samples, the better. The possibility of getting better results. That is the performance that we always want to improve upon. So we give the data set, we can divide the data into 2 or into 3, depending on the type of model you want to build and the sample size that you have access to. So when we divide the data into training, the system will now consider this input, these 3 inputs, which we call them features. in the classical machine learning science, we call them features. Features. So you give this feature for this sample, then you also provide the target. Maybe it was 20.6. This one, you also provide it was 35.6. So the system will try to monitor it, learn it, try to understand what is the relationship between X1, X1, X3 that is making us to get this output. Why is this one value, this value, why is it getting 35.6? It to try to understand it is what we call the learning process. And that is the big change in paradigm that machine learning brought to the table. Then you would are learning from the past data set. Why was this? Why is this one like this? Then once we are done with the learning process, we check the performance, so which you have to decide which performance measure am I going to use. It depends on the area you are modeling. You go into literature that has been more earlier work and see the way they check the performance. If you are the first one to work in this area, then you can go for the standard performance measures. If you are dealing with regression problem, you are predicting number like this example, then you'll be talking of root mean square error. Try to find the root mean square error and try to minimize it as much as possible. So you may also have to try to check the correlation. How is the predicted value correlating with the experimental value? So once our training is okay, then we bring in the other data sample that we divided and kept. Then in that case, we are only going to give the X1, X2, the input to the system. Although we have access to this data, but we will not give the value to we let it predict the outcome of this testing set. We call it testing set. And then based on the outcome, we'll compare the prediction with the original value that we already had. We put it away. We now measure how far is the prediction close to the original experimental data that we have. So if we are doing fine, that means our model is doing great. If not, we might have to go back and then do some other processing to make it better. So this is just again summarizing and revising what machine learning model does in the case of supervised learning. So in short, what machine learning model entails, we don't talk of model until we are done with this process of training and testing. So after training and testing, the final outcome is what we refer to as the model. We can now take this model, instead of going to your laboratory to spend several hours or weeks to estimate this experimental value. We don't need to do that because we already have a model that has been tested and trusted. You just bring in the value, and often these features are very easy to measure from your materials. Just put it on a scale or on a particular machine, it you all those features. Those things are usually easy to measure, but this is why the target, they are always difficult to measure. Usually people like week in the lab before they can measure it. For example, in the case of when an oil and gas problem solving, there's a problem we call permeability. Permeability, which is what the oil exploration engineers need to know if that the permeability of the soil is okay. So usually they have to take permeability from the field at every meter. Each meter you have to take a sample of the soil and take it to laboratory that is thousands of kilometers or hundreds of kilometers away from the rig, the digging site, to go and make the permeability. So imagine the time it's going to take. At every meter, you have to take it there. At every meter, you have to take it there. However, with machine learning model that has been built, as the features are coming in, which is very easy to get, it is going to be predicting for them the permeability is this, the permeability is this. And then the rig engineer can continue to take the right decision. Okay, we can continue, or we should stop the exploration at this point in time. So it will cut down the time that it's going to take for you to estimate drastically. And the same thing goes to if we are talking of classification problem. We want to predict if somebody is sick. One of the intervention area I'm personally passionate about is can we decide if somebody is sick at the very early stage, especially with chronic diseases. Often they're not people are sick for years, but there are usually no symptom. The moment symptoms start coming, they if I had a complaint, headache, they took him out to the clinic and they check. Comprehensive test revealed that he has also chronic disease and it is late stage. Late stage. Usually they diagnose chronic disease at late stage. The question is, why do we wait for it to be late? Because the disease does not present the symptom that will make this person to appear and to go to the clinic for checkup. By the time the symptom is coming out, it is usually already late. And we stop this, what can we do? So say, okay, can you bring for us data in the past? All those people that have suffered from this disease, they are always this data set is available, they are it's wasting away in the clinic, either on paper or in their system for those that have automated systems. Why can't we bring these data sets that are often considered useless, train a machine learning model? Once we have this model, we can always use it to estimate. Even people who are going about their activity, in their day-to-day activity, that we think they are okay, but some of them already have underlying diseases that is gradually consuming the organ. So why do we need to wait until it is late? We can use machine learning model that we have trained after providing adequate enough data. Enough. When I say enough, what is enough in one feed might not be enough for another feed. We'll come back to that one another time, God willing. Then once you have data, then you have to add it to the algorithm. Which algorithm is good for me? It depends. There's always a guideline. Always start with simple algorithm. And one of the very simple algorithm is what we refer to as the K nearest neighbor. It's like, show me your friend, I will tell you the kind of person you are. So if 2, 3 people that are closer to you based on characteristics, if they are suffering from a disease, maybe you share the same returns, the same parentage. One of them have suffered from this. You share the same weight, you share the same height, and some characteristics that can easily be determined, be measured, be hashed, be found out. Then the system may be able to predict that this person might likely suffer from so disease, so that you can take precaution, either to avoid it from becoming complicated before it can be detected. We just chose those 2 examples in the field of material, where your model can now be used to estimate your material properties rather than the lab for several weeks or hours. And in the case of medical, it can easily detect if somebody is sick even before any symptom is presented. Because often than not, by the time people have presented symptoms, it is already too late. We've had cases of someone that's been very okay all along, all throughout his life. Just headache, few days of headache. Then he presented himself at the clinic and the diagnosed that said, oh, late stage tumor of the brain. See, and once they say late stage, that means it's almost done. There's practically little or nothing that could be done. So machine learning can help us to revolutionize medical practices and other area of our individual specialization. So now get it right. When we talk of algorithm, it is those algorithms like decision tree, neural network, public machine, deep learning, and host of others that we refer to them. However, the principle is to start with simple algorithm first. When you add data into that algorithm and the training process plays the way I've explained, then you are going to have a model. So the outcome of this process is model, which you can then use in your future prediction or estimation, or as the case may be. Therefore, we say that machine learning model intend to determine the optimal structure in a data set in order to achieve the assigned task. So This is what a model does. Before you can get this model, you have to check the hyperparameter of the algorithm, train it until it is working fine, provided we have enough data. People do ask me questions. How much of data is enough? There's no amount that is enough. It depends on the problem you are solving. And that's why I always say, let the data speak. Let the data speak. Don't make too much assumptions. Bring the data you have, put it into the system, run the experiment, and then see what you are getting. If you do your training and then test the model, you can do 2 straight testing. Divide your data into 3. First one for training, second one for validation, another final one for testing. You are really sure that the model you are sending to the world is okay. The one you want to deploy, it's okay. Then you are saying that if you have a new case, you're going to get it right. So this is the essence of having a machine learning model. So data plus algorithm will produce what we refer to as the model, and that is the final outcome of machine learning modeling process. Now, and the model actually results from learning algorithms that apply on training data set. So you have your training data set I've explained. You bring in the algorithm, being the key nearest neighbor, and do the hyperparameter optimization. You arrive at the model. So model different from algorithm. Algorithm is that in the alone step-by-step procedure to solve a problem that can guide our machine on how to proceed with the training. The moment data set is now added to it and the right procedure is used, then it will generate what we call a model. So when people say, hey, I got a new data set, which kind of model should I use? No, you don't use a model. You are going to use algorithm. So that algorithm using the data you have before you can generate a model. Now, so moving further, now let's look at the machine learning building block, which could be viewed as containing 4 basic steps. 4 basic steps. In number 1, the data preparation stage. Here you are going to prepare your data. Which kind of data do you have? How do you want your data to look like? The data may not be in the form that you want it to be. So how can you make it better? Then we have feature engineering. Sometimes you have the data, but how do you make it into feature? Are the present features, are they okay? Can they support the system we are dealing with? Do we need to create more feature? For example, we have date of birth. Usually we have date of birth where it's going to give you the day, the month, and then the year. And we made this is a single feature. And we break it into 3 features. They separate. We want the day you are born, we want it separated. Then I want the second feature to be month. And I want the third feature to be year. Maybe it's going to make a big difference in getting to understand the intricacies of the hidden message within the data set. Then we have to always apply, let the data speak. That is why we have to first of all model with the original data that comes to us. Don't do too much modification to your data set at the beginning. Maybe after modeling using the standard date format, considering the date of that at one. After trying several things, we notice that we are not getting something better. We may have to decide, okay, why don't we break this back into month as a feature, date as a feature, and year as a feature. Just an example of what we do in feature engineering. Sometimes you might have to add 2, 3 features together to make one, or you have to break one into several features. And also other things that are involved in feature engineering. And sometimes we might have to do total data transformation. We will come back to all this, some of these details later on, God willing, inshallah. The next thing is this. The third one is the data modeling. And this is where you are going to need the algorithm. We call it the data modeling procedure. This is why you're going to need the algorithm. And there are different type of algorithms. You bring in your data set, bring it in, and then try to see, run the experiment, train it, and then check the performance of your performance measure. You check it and see how far you can go about it. This leads us to the iterative process of machine learning process. This one is an iterative process, and that's why it's supporting the idea of letting the data speak, letting the data speak. That is, since you can always go back, you have that freedom to go back and make things better. So don't spend too much time processing your data set, because often sometimes too much preprocessing without necessity leads to data mutilation. I call it data mutilation. You may end up mutilating your data mutilation. Because you want to preprocess, you ended up doing what is not supposed to be done. Because some data set, the hidden information within them that you want to extract using machine learning algorithm, they are so easy and straightforward with the original data set. If you go with too much preprocessing like normalization, we discussed last week, you may end up missing the important information. Now, by the time you are running, you use your algorithm on the data set, it's not able to detect it. That is why it's always good for you to start with the original data. Good. Once you get your data, let it go straight. There are some very important preprocessing stage, like missing value. We talk about that one in detail later, inshallah. Like that missing value, and even then, you can still use decision. Decision tree algorithm will work on even when you have missing value without any complaint. However, some algorithm will not work if there is missing value, even a single missing value in your data set, like support vector machine, it will not work. So in that case, we can say that missing value is almost very important as a preprocessing stage that you need to do. Aside missing value, every other preprocessing stage, preprocessing activities could be considered optional. So go with the original data, model it using decision tree. If you suspect there's the missing value and you are yet to treat it. Otherwise, start with KNN. KNN is number one of the very simple algorithm. We call them lazy classifiers. So once you are done with that, do your hyperparameter optimization, hyperparameter tuning, then go back. The result, check the performance measure. Is the result okay? If it's not okay, go back. Do hyperparameter optimization. Is it okay now? No. Keep going back. You have to change the algorithm to another one. Neural network, support vector machine, keep changing them and doing hyperparameter. And sometimes we might have to go to ensemble, where we have to combine many different machine learning algorithms into one to use the power of committee decision making. And it has been established that when you put them together, you get better results than individual. However, it's not all problems that need that solution. It's like I always want to use sledgehammer to kill and hunt. You may end up not be able to kill or fly. You may end up missing that fly and you break your table. We don't do that in machine learning. We are cognizant of that. You use simple algorithm first. It is when simple algorithm is not able to solve your problem, then you can advance to more complicated algorithms. And always remember the principle of letting the data speak. Because using the most complicated algorithm does not guarantee that you are going to have the system that you wanted. Now, so moving forward, so you have your performance measure check, you have to go here. If after doing hyperparameter optimization, after changing different algorithms, yet you are not getting the performance measure you envisaged, then you may have to actually go back to feature engineering. maybe those features are not well done, or you may have to go back to data preparation outrightly. You have to do some pre-processing, noise removal, normalization. Maybe sometime we might even have to do under feature engineering PCA, principal component analysis, whereby we are going to transform the entire feature. You can start with like 15 features, we'll transform it to like 5 features. Each of those 5 features, they are never made part of the original feature. Total transformation. But these are kind of very heavy reprocessing that we often discourage them, except when it becomes very, very important. You have tried to let the data speak as they are, original data, but you are not getting closer to the expected outcome. Then you have tried different processing, noise removal, normalization. Then you may have to go to those kind of stuff because they are going to totally change the data you started with. It's not always the best option, but we go to such option as a extreme option in case we are not able to achieve what we could have gotten using the original data set. So in essence, we say that machine learning model process is an iterative procedure. Iterative in the sense that you can go forward and then you can also go back. So shedding more light on each of the procedure, the processes, stages, data preparation. This is why you look into how can you import your data set, which kind of raw sample we are going to use, what are the most common and data cleaning methods to use. There are several data cleaning, like noise removal, like normalization, missing value treatment. There is also what we call outlier treatment. However, apart from missing value that you may do at the beginning, which is very important because some algorithm will not work, every other pre-processing options or processes, they are optional. And I strongly recommend you to let the original data talk. It is when the result is not good, then you can go back and treat noise and treat normal and normalize the data, the outlier. Sometimes outlier being present will be an advantage to the data set itself, especially when you are modeling anomaly system, anomalous system that you want to detect if there's a credit card fraud. Because the fraud is an anomaly in the data set. So you don't go ahead and remove the outliers because you may be removing the data that you actually need. So, but when we work with normal data as much as possible and we're not able to make headway, then we might have no option than to go back and do all those kind of processes. We also have the feature in engineering, like how do you turn raw data into relevant data sets? What do you need to do? So you want to turn your data to meaningful form so that any algorithm can use them. So you think of these features, they are interesting, but they don't make any meaning. So how can you make difference between useful and useless data in a huge data set? That is, how do you select the appropriate features? Again, advice here is don't assume one feature is not good at the beginning. We are encouraged to bring on board as many features as you are. Then machine learning has some of the principles that you can use to select the features. We call it feature selection. You use the feature selection procedure. There are several feature selection methods you can use to check and see which of these features will work for us as we go. Because if you just throw away all the features, some expert opinion, we respect experts, but I tell people machine learning and AI technology is a kind of big game changer, actually, so that sometimes challenge some of the established principles, different fields of life. And because data set format is changing, for example, we have ways by which medical doctors do diagnose patients suffering from diabetes, for example. But this has been taught to our medical doctors since long time, several years ago. The same principle is still being followed. Meanwhile, we know that our food intake are changing every day. The GMO, genetically modified organism being food, which is also changing the characteristics of human system. So now machine learning is now having an edge over those old methods of diagnosis. That's why sometimes we encourage you to bring on board all the features you can lay your hand on. Let the machine learning select the one that is good for you. See, if you go settle doctor, say, okay, for us to diagnose diabetes, we check this, we check this, we check this. It may be possible that the present data set you are having, those features might not be the most important to detect because it is from another environment, it's from another generation of people who are subjected to different type of food, different type of lifestyles, spending more time on phone. To diagnose eyesight problem now, definitely it's going to be totally different from what you used to be in the past. So a lot of things are changing. So the data science, machine learning, and AI is presenting very unique opportunity. I remember there was a critical case of uh, oil and gas problem solving, where the engineers agreed that feature 1, 3, and 5 were the most important. And they were using it to monitor the rigging whenever they are carrying out rigging. So they have been using these 3 for long. But when they brought in data science, data mining, it was able to identify that there was another one that they actually removed because they thought they were not important. One of that one plus one of these 3 was getting better results than the 3 they have been using. This is being detected day in, day out. So things are changing. Of course, it's good to get expert opinion, but at the same time, let the data speak. Bring all the data that is available, bring all the features on board. And then this machine learning run on those data sets and then recommend, select those features that happen to be the best for the problem at hand at a particular point in time. Maybe another data set from another location may not support the same principle that the data set from another location supports. Then the data modeling stage, here you are going to look into things like what are the different type of machine learning algorithms, which one should you choose to build your model. So for a deep analysis of several machine learning algorithms, we have several of our videos depth into it in the past. We can check out the YouTube channel on this, especially for those that are joining us for the first time. So I want to believe the coordinator will guide us through how we can connect with the forum so that we get lists of some of the recommended videos for us to watch and understand some of these algorithms and how they work. So, yeah. Then the last but not the least too, the performance measure. Yeah, again, we are going to talk about what is the right method to assess the performance of your machine learning algorithms. What is the right method to assess the performance of your machine learning algorithm? Which indicator should you use? The performance measure, they are the way to see if your model, the model you are building is doing fine. It depends on the area you are modeling. In engineering, they have their own way, what they want to model. So the first point of call is to check the literature. Go into the literature, what has been done in that area, see what are the established performance measures. Mostly if the regression problem, where you are predicting numbers, root mean error is always used, and means absolute error is also there, means percentage error. There are several ones you can use, but check which one is being used there because you have to compare your work with the earlier work. But if you are the pioneer person in this area, then you may go for the most popular one, like this one, then the correlation coefficient. That should suffice it for you. Because you are the pioneer in that area, you can decide what you think is a means of checking the correctness of the prediction that is coming. But if you are dealing with classification problem, then there are standard classification performance measures, like the accuracy, which is not enough. You have to check the confusion matrix. You have to check the confusion matrix. You have to look at the precision And then the recall. All these are really made available for you by the algorithm that you have run using the platform, whichever platform you have elected to use. And then for the performance improvement, this is where you have to be doing what if analysis. That is what are the reasons why your machine learning model is not performing well. Is it my data that is bad? Did I do enough hyperparameter optimization? See, what are the common techniques to improve the performance? Ranging from hyperparameter optimization, very important. You have to the hyperparameter of your model. Sometimes you may have to change the algorithm. The algorithm is not able to understand what you think of the data. And sometimes you might have to use ensemble models, more superior models that may give you the result. May, because no one can guarantee that a method will work for a particular data. Always remember, let the data speak. You have to keep checking and changing. And also sometimes you might have to go back. The feature engineering, maybe the shots your feature are not correct. You might have to go back and do something. Especially if you have many features, then you need to do feature selection because the more the number of features, the more the number of samples that you need. The number of features are many, but the number of samples, they are often limited in number. Then feature selection becomes very compulsory because by doing feature selection, you are trying to solve the problem of exponential, what we call cost of dimensionality. The more the number of features, the more the number of samples you need to run the experiment, and the number of samples are often limited. So somebody gets stuck. So the only way out is for you to go back and do feature selection, let some features using some of there are several feature selection method also. We can take that out. I believe we covered some of them before. Use them, take the features, see which of those features are working fine, and then you can get better results. And sometimes you might have to go back totally to the iterative process, whereby you have to go to the data. The data is wrong. We have tried everything possible to improve the result. We are not getting anything acceptable. Then that means your data is not good. You have collected the wrong data set. You may have to go back to the drawing board, go back to the field again, and get new set of data sets that may model that area very well. Because you have to select your data carefully. If you are modeling something that has to do with human body, then you have to get data from that human body. Age, height, however you want to model human body, you want to predict somebody sick, you are getting data about his environment alone. You are not even assessing his own personal issues. The data may not work. I want to be able to predict a particular neighborhood that may suffer attack or violence by maybe during election or whatever. Then I have to get data that relates to the environment, to the neighborhood, to be able to get something reasonable. But sometimes, because of lack of understanding of this concept, people just get data randomly, which may not work. So the iterative process makes it very flexible. Sometimes just going back to algorithm engine may work for you. If you're engineering, preparing pre-processing steps may also assist you. Sometimes you may have to altogether do away with that data and get another data that works for you. This is what we refer to as the machine learning modeling process, which is iterative. And then we are able to talk about differentiating between algorithm and what a model is, which is the outcome of using data to train the machine learning algorithm to produce the model. And of course, machine learning concept has been explained. I believe because of our time, this is where we need to have it. Call it a day. Thank you very much for coming. Wish you all a pleasure.